All right, guys. Yeah, here we go. This is part two. Mhm. Let me see. So, last time we were looking at paper one. Yeah, paper one. And we didn't finish paper one. And so this functional skills hour is going to be an opportunity to finish what we started. If you're just tuning in, remember that these sessions are designed to help you along with functional skills maths. We just go through functional skills maths past papers for an hour. I go on for an hour. If you can bear with me for an hour. And so yeah, it's not very complicated. So last time we were doing this paper and I wanted to cover this question again because this question it gave us some trouble. I should be more specific. It gave me some trouble. I had to think about this for quite some time before I came up with an answer, and the answer was quite convoluted. It wasn't the most elegant solution, but I thought about it some more, and there's a much simpler way to answer this question. And so we'll begin with this. So okay, let's begin. We have Samir. Samir is a roofer. Here's a section of a roof made from straight pieces of wood. Samir knows that the shaded triangle is an equilateral triangle. The line DB is a line of symmetry. You just highlight that line, DB. And the line ABC is a straight line. Let me highlight that line, ABC. The size of the angle marked X indicates the pitch of the roof. Okay, find the value of X. So we spent some time, last time I gave a very convoluted answer, right? We started off by noticing that this is an equilateral triangle, so the internal angles must be 60 degrees, all of them equal, because there's 180 degrees in a triangle. And then somehow I kind of fudged it and I said, well, this is equal to 60 as well. If this is a line of symmetry, these are equal. Right. And then we went through that. If you remember, if you don't, you can always go watch the previous video on YouTube. But that's how I approach this is step by step. Um, and it almost seems like this is what they want you to do because they tell us that DB is a line of symmetry. So it almost seems like that is what they're encouraging you to do. To notice that this angle here is also equal to 60, and whatever this angle is also equal to this angle here. But you can ignore all of that. And instead of approaching it that way, I want you to notice that this line DB, right? This line DB, uh, and this line here, we can say that DB, first of all, I'll be more precise. These two lines are parallel. DB is parallel to this line here. How can I be absolutely certain that that's true? Because, where does it say? It tells us that um, we can be pretty much certain that AD is a straight line. We're pretty much certain. This is a straight line. Okay? We're not told that explicitly that this is a straight line, but it's a reasonable assumption. It's a reasonable thing to assume that AD is a straight line. If AD is a straight line, that means these two are parallel. Why? Because this triangle here is similar to this larger triangle here. It must be because they share an angle. Well, they share an angle here. And so they must be similar, right? And if that's true, these lines must be both parallel. Now, if that is true, this line is in blue is this parallel to DB. We know about alternate angles, don't we? Alternate angles. Alternate angles tell us that the angles, like so, when you have one pair of parallel lines, these angles are always equal to each other. These alternate angles are equal to each other. That is, the angle formed between the diagonal and one parallel line is equal to the angle formed by the diagonal and the other parallel line. So this is 60 as well. This is known as the alternate angle theorem. Classic. So if this is 60, and we know that this AD is a straight line, that means this must also be 60 because there's 180 degrees in a straight line. And if this is 60, and we know that this is 90, because remember, this little square means that it's a right angle. And a right angle means it's 90 degrees. So if this is 60, this is 90, their sum is 150. And since there's 180 degrees in a triangle, x must be 180 minus 150. So x is 30 degrees. All right? So just like that, we got to the answer. I kind of explained it in a very long way, but that was just a lot of background. We just notice these are alternate angles. This is an equilateral triangle. These are alternate angles. This is 60, therefore x is 30. And so looking at this table here, you can be pretty sure that if x is 30 degrees, the pitch is 7. Just like that. So that's it. That's really it. This question could have been answered much quicker. Yeah, that's that. Now, let's move on. We managed to do this question. We went quite far, but we didn't manage to get to this question here. So, what we'll do in this lesson is we're going to complete everything from question 9 onwards. And if we still have time by the end, we'll continue on to paper 2. Second paper in our list. All right. But I hope that was useful. I hope that made sense, chat. Let me know. Let me know if that's making sense to us. Tell me if that explanation above was sufficient. Yeah. Okay. Yeah, what happened to my background? Yes, if you remember last time I was in the Bahamas. Today it looks like I'm not in the Bahamas for whatever reason. Yeah, that's a very good question. I could try to bring back but I think it's not gonna work. I think there's been some issue with my flight, so I'm not really at the Bahamas anymore. No, it's not working. Anyway, no questions. Let's move on to number nine. Magda wants to compare the population density of the two largest countries in the world. She can use the following formula. Here it is. Canada has a population density of 3.57 people per kilometer squared. Russia has the following population and area. Magda thinks Russia has a greater population density than Canada. Is Magda correct? All right. This question, we simply have to use the formula to try to get to the answer. All right. K is the population density. P is the population. M is the land area. So we simply have to substitute these values into our equation. Let me do that right now. We already know Canada's, let's say the population density for Canada, we already know is 3.57 people that they tell us. But for Russia, we have to actually calculate this using the formula. So it's going to be the population of Russia in millions over 2.59 times the land area. This is the land area. 6.593 million square miles. So I just have to put this in a calculator and then we'll see what we get. So let's have a look. Let's see. Let's pull up. So here we go. We want to do 143.96 divided by 2.59 times 6.593, 17.07. Oh no, there it is. Let me do that again. Let's see. There we go. 8.43. Yeah, to two decimal places. 8.43 people per kilometer squared. So, Magda is in fact correct. Russia has a greater population density. She is correct. Pretty simple. Next, 10. Whoa, we have to work out this. This is a mixed number calculation question. So we want to work this out. Remember, with mixed numbers, what you got to do is you want to convert everything into an improper fraction, first of all. So right now they're mixed numbers, but we want everything in terms of fractions. Okay. So looking at 3 and 3/8, we know that a hole, if we have three holes, one hole would be 8/8. So 3 holes will be 3 lots of 8/8. So 3 and 3/8 is equal to this. That would be 24/8, because 3 times 8 are 24, plus 3/8. That's 27/8. And we already know 9/8. So we just want to do 27/8 minus 9/8. All right. Now that's actually 18/8. Right. So if we want this as a mixed number, we want to convert this back into a mixed number. We just see how many times 8 goes into 18. Be twice. Right? 8 times 2 is 16, so we have 2/8 remaining. Here we go. 2 and 2/8. Use estimation to check, to show a check of your answer. It's very interesting. Well, we can basically estimate that 3 and 3/8, that's around 3, right? 9/8, that's around 1 hole. So this is around 2. So this is around correct. 2. That's pretty close. All right, Emilio makes metal fences. He's making a fence using this diagram, using this design. The fence will need 3 horizontal metal pieces of length such and such, 2 tall metal pieces of length such and such, 5 medium metal pieces, and 6 short metal pieces. I see. So let's look at this very carefully here. So we have 3 horizontal metal pieces of length 1.8 meters. These are the 3. We have 2 tall pieces, metal pieces here and here. All right. We have 5 medium. So these are the medium ones. 1, 2, 3, 4, 5. Right, and finally we have 6 short metal pieces. 3, 5, 6. There we go. Hopefully that highlights everything as you can see. Now the heights of the tall, medium, short metal pieces are in this ratio. Let's see. So how many meters of metal in total does Emilio need to make the fence? Very interesting question. Very interesting. So currently we only know the lengths of the yellow pieces and the blue pieces. We don't know the length of the green and the red. Right? So let me highlight this so it's really clear. The tall, that corresponds to the green, to the blue, sorry. The medium to the green, and the short, the red. So in essence, the ratio between tall, medium, and short is 9 to 8 to 7. And since we know the length of the tall pieces, and we know the ratio, we know its ratio, its relationship to the others, we can figure out the length of the others. So let's do that. We can conclude If this is the ratio of the pieces together, that means you can say that if we have three of these pieces together, we can consider them as being composed of 9 plus 8 plus 7 parts, equal parts. That is 24 parts. 9 of those parts would correspond to tall. So let me just draw that out here. Let's say this is the tall piece. This is the medium piece. Put it here, medium piece. And this is the short piece. Okay. There, it would be composed 24 parts, right? 9 of them would be tall, 8 would be medium, 7 would be short. Okay. So 24 parts corresponds, or I should say, 9 parts correspond with 1.14.44 meters, sorry, because this is blue, right? This is the tall. Therefore, 1 part corresponds with this divided by 9 meters. Therefore, we can find 8 parts and then 7 parts. 8 parts would be 8 times this. And 7 parts would be 7 times this. I hope that makes sense. We started off with what we know, which is that a tall piece corresponds to 9 parts, and 9 parts would correspond to 1.44 meters. We scaled that down, then we scaled it up to find the length of the medium and the short. Okay, let's actually find what these are. Let me do that. This one is 1.28 meters. And this one, 1.12 meters. All right. From there, we know the length of every single part. Remember, medium, short, tall. All right. Now we just want to add all these up. So let me do that right here. We know that, let's count how many. Let's put everything. The horizontal, there's 2 of them. The tall, there's also 2 of them. The medium, there are 4 of them. Sorry. The short, there are 6, I believe. And let me correct this. The horizontal, there are actually 3. If you go up and check, you'll see. All right. There's 1, 2, 3. So this is actually going to be 1.88 times 3. This is going to be 1.44 times 2. The medium, that is 1.28 meters. And the short, that is 1.12, I believe. Yeah, meters times 6. So really, let me just, we want to do this. And then sum it all up. And that will tell us the total length of metal we need. Let me do that right now. 2 times 1.88, that's 3.76. This is 2.88. This one is 5.12. This one is 6.72. If we add all of this up, we'll see. Let's see. There we go. Here we go. That's 18 meters and 48 centimeters in total. There we go. We're done. Right. Emilio needs this amount of meters. 18 meters. 18.48 meters Emilio needs. I hope that made all the sense that it needed to. And yeah, do let me know. Oh, that is my bad. I made a slight blunder. 1.88, that's not the length. It's 1.8. So that's me scrolling back and forth and forgetting. So to correct that, we just have to subtract 0.24 from this answer. We'll get 18.24 meters. Okay. So let's get rid of this. 18.24 is the actual answer. Yeah, just a slight blunder. Okay, cool. I hope that made sense. Any questions? Anything to clarify about this? Uh, so yeah, this ratio part. Yeah, that seems like this is the major thing causing issues. You can think of it like this. A ratio is a relation between numbers. And so the relationship between the tall, the medium, and the short pieces is as 9 is to 8 and as 8 is to 7. Right? As 9 are to 8 and as 8 are to 7, so the tall is to the medium and the medium is to the short. It's a relationship, it's an analogy. That's what a ratio kind of is. And so we can consider that if we had 9, 8, and 7, we would have 24 in total. Right? Right? And 9 of those would correspond to the tall. 8 of them would correspond to the medium. 7 of them would correspond to the short. Right? And so what we want to do is, in order to find uh, the length of these two, the medium and the short, first of all, we know the length of the tall is 1.44 meters. Right? We're told that here. And we know that this, in terms of a ratio, corresponds to 9. Right? 9 parts. So from that, we start with what we happen to know. Then we work from there. We can find the lengths of the other parts. Right? 9 corresponds to 1.44. So 1 must be 1.44 divided by 9. Right? So 8, which corresponds to medium, we can find that by scaling by 8. And 7, we do the same. We can scale by 7. Okay, but of course, you really to know this, you want to go through the course. We can't go through this right now. Hopefully that helped a little bit. Cool. Let us move on. I encourage you guys, if you really want to go into more detail, um, come on. I want you to join the course and see how you like it. Um, yeah. Let's see. Okay, question 12. We have a table showing some information about 60 holidays bought by customers at a travel agency. All right. All right, travel agency. I don't think anyone's been to one of those in around 20 years, but let's see. Um, hmm, complete the table above. So, okay, first important thing, we're already told there's 60 holidays, right? So right away, we can see that that's right here, 60. So if 34 of them correspond to couples, the rest would correspond to families. So there's 60 minus 34, right? That corresponds to 26. 26 remain. Now, all inclusive, that's 18 plus 14. That's 32, right? If bed and breakfasts sum up to 23 and 10 of them are families, the other must be couples. So that's 13. 23 minus 10. It's 13. Finally, we can see that this row here should sum up to 30 as well. 23 plus 32, that's 55. 60 minus 55, well, that's 5. So this is 5 right here. 5, book only for a room. And if 5 book only for a room, 3 of them are couples, the remaining must be families. That's 2. This is 2 right here. I hope that made sense. So everything hinges on this fact here. There's 60 holidays. From there, we just follow the logic. Now, a customer who bought a holiday at the travel agency is chosen at random. What is the probability that this customer bought an all-inclusive holiday for a couple? Let's look at the table. An all-inclusive, so it has to be within this column. But for a couple, well, that's right here. So it's 18 out of 60. That's our answer, 18 60ths. But they ask us, give your answer as a fraction in its simplest form. So we want to simplify this. Both 18 and 60 are divisible by 6. So we can cancel a factor of 6 to be 3/10. 3 and 10 share no common factors. So we're done. 3/10. Now the travel agent says, of the couples and families who bought holidays, the couples were more likely to have bought an all-inclusive holiday. Is he correct? Well, let's see. This is a conditional question. So we want to say of couples who bought holidays. So couples and families who bought holidays, couples were more likely to. Okay, let's see. Let's see if he's correct. So if we're looking at all inclusive again, we can see that 18 couples chose all inclusive, but 14 families chose all inclusive. So he's correct, right? Couples were more likely likely to have bought an all-inclusive holiday, but maybe not because the question is how many couples were they? Were there? We would have to consider relative to the number of couples there were. So 18, yes, absolutely more couples chose all-inclusive, but there were 34 couples. So 18 out of 34 couples chose all-inclusive. Meanwhile, there were 26 families. So 14 out of 26 families. So we want to find what both of these are in terms of their in simplest form. You want to compare these. So 14, 26, this corresponds to families versus 18, 30, was it 34th? Yeah, 34ths. I want to see which is more, which has a higher probability, which is larger. Let's cancel both of these. Cancel a factor of 2. 7/13ths. Here we can cancel a factor of 2. That's 9/17ths. Now, both of these are prime numbers, so we can't directly compare them. What we can do is let's introduce a factor of 17 here and a factor of 13 here so that both of them have a common denominator and we can compare them directly. So that's going to be 119 let's see, 221sts versus 117 221sts. So actually, he's incorrect because if you're a family, if you're a family, you're actually more likely to have chosen an all-inclusive than if you're a couple. Because 119 out of 221 is more than 117 out of 221. So he is incorrect. He is incorrect. Or they are incorrect. They are incorrect. Right? 119, 221st is actually more than 117, 221st. So the probability of a family choosing all-inclusive is actually more than a probability of a couple choosing all-inclusive. It's a very subtle question. Very easy to miss the marks here. So yeah, that's how you answer this. And that's it. We've reached the end of paper one. Look at that. That's not bad. I think yeah, how would you say that went, guys? Mm-hmm. You're thinking about the World Cup? Okay. Of course, of course. Yes, yes, yes. Of course. I mean, who isn't supporting England? Is anyone supporting the US? No, no one's out here supporting the US. Of course not. No, England all the way. It's coming home for sure, for sure. It's coming home. Every year, every single 4 years, we say it's coming home. It's coming home this time. This time, it's coming home. It's different this year. I can feel it too. Can you feel it? I can feel it. I think we're gonna win this year. There's something in the air, something in the atmosphere. Yeah, guys. All right. Perfect. This is it. This is it. We've done. We've done what we need to do. We have 20 minutes. So in that time, I can start paper two. I think easily we can start paper two. What I'll do is let me let me show you what needs to be done. Paper two. Here we go. What we'll do is we'll start paper two, section A. In the next 20 minutes, we should be able to finish. It's meant to be take 25 minutes, but let's see how we do. There's no need to rush. I won't rush, you know. These are meant to help. These are meant to be useful for you guys, and so I will not try to rush. I'll just go at my normal pace. All right, remember, write your name, center ID number, candidate number. Now, all of this, remember the functional skills maths, it can be written online and on demand. So some of these are kind of, you know, not relevant for you because this is an exam that can be taken online. Okay, let's begin. Section A. Here are the times in seconds 5 athletes took to finish a 100-meter race. Find the median. All right, so remember the median is the middle value when we order everything. So let's order this. Smallest to largest. So smallest, followed by this, followed by this, followed by these two. All right. This is our data ordered from smallest to largest. Next, we just get rid of each of them, all right? Canceling until we're left with just the middle term. All right, so the median must be 11.05. 11.05. I'll write it here. Now the mode, that is the most common value, the value that's repeated the most amount of times. We can see that 11.12 is repeated twice. No other value is repeated as many times. All right, let's find the value of h when a is 10, b is 8. So h is the square root of 10 squared. 10 squared, that's 100, minus 8 squared, that's 64. 100 minus 64, that's 36. Square root of 36, that's actually just 6, right? The square root asks, what number do we multiply by itself to get 36? Well, that's 6. So h is 6. Alex is the manager of a hospital canteen. He reviews the meals the patients choose. On Monday, there are 240 patients in total. A third of them chose pasta. 3/8 chose beef stew. The others chose chicken. Okay, how many chose chicken on Monday? All right, so right now we want to first look at things from the perspective of fractions. Before we even deal with the absolute values, let's just look at the fractional. If a third choose pasta, 3/8 choose beef stew, the others must choose chicken, right? And if we consider all of them as a whole, well, that's one whole. So if we want to find what fraction chose chicken, we would take one whole and subtract 1/3 and 3/8. This is the fraction that shows chicken, right? Shows chicken. 1 minus 1/3 minus 3/8. Okay. So to do this, let's bring everything into a common denomination. So 24 is an easy choice, right? Right? 3 and 8, both 24th. So let's introduce a factor of 8 here. Introduce a factor of 3 here. Introduce a factor of 8, right? So that's simply 8/8 minus 8. Oh no, sorry, my bad, not 8. Factor of 24. 24 24ths minus 8 24ths minus 9 24ths. Right? That's going to be what? 24 minus 8, that's 16. 16 minus 9, that's what's that? 7. So 7 24ths corresponds to the fraction of yellow that chose chicken. So we simply have to take our total and find 7 24ths of 240. Right? So 1 24th of 240 will be 240 divided by 24. It's 10. Therefore, 7 24ths would be 70. So 70 chose chicken. That's it. Hopefully that made sense. So again, the key here is that we had to reduce these fractions into a common denominator. It's a common denomination, you could say. The common denomination was 24ths. We brought everything into 24ths, and so we could easily just subtract numerator from numerator. Right? That's how we easily found that, yeah, we're interested in finding 7 24ths of the whole. Right? So, yeah, that's it. Next, Roberto paints advertising boards. Each board is in the shape of a triangular prism. Here we go. Each 1 liter of paint covers this amount, 10 meters squared. Roberto has 2 liters of paint. Roberto has 3 advertising boards to cover with paint. He needs to cover all 5 faces with paint. The area of each triangular face is such and such. Will 2 liters be enough to cover 3 advertising boards? Good question. Well, simple question, just many steps. So loads and loads of marks. We can start by noticing that if 1 liter covers 10 meters squared, 2 liters must cover 20 liters. Liters would cover 20 meters squared. Right? That's crucial to this question. Now, because this is the constraint, right? The amount of paint is his constraint. Now we want to find the total area of 3 advertising boards, right? The surface area of 3 advertising boards. To do that, we want to find the area of 1 advertising board. So, and to do that, we can just look at this diagram and, figure it out. We're told that that each triangular face is like so, this one, 0.12 meters squared. And notice there's 2 of them. So 0.12 meters squared, 0.12 meters squared. Now we have 1, 2, 3 rectangular faces. To find the area of one is simply going to be base times height. So the area of one of these is going to be base times height. Now, currently we have millimeters, right? So we want to convert these into meters. It's important to know that a millimeter corresponds to 1,000th. So a millimeter is the 1,000th of a meter. So this is actually equal to 4 meters. 4,000 millimeters is 4 meters. 500 millimeters is half a meter. Just divide it by 1,000. Right? Okay. Now, we have 4 by 0.5. That's an area of 2 meters squared for each of these faces. Now, there's 3 of them, so that's going to be 2 times 3, 6 meters squared. Now, 6 meters squared plus these 2 triangular faces, it's going to be what's that going to be? Let's see. 6.24 meters squared. That's the total surface area of one advertising board. So 3 of them would be this times 3. So let's find that. This is one board. 3 of them would be 6.24 times 3. All right. So I'll actually just do that using the column method over here. 3 times 4, that's 12. 3 times 2 plus 1, that's 7. 3 times 6, it's 18. So 3 boards are 18.72 meters squared. 2 liters of paint, he has enough. This is less than 20 meters squared. So yes, he can. He has enough paint. And we're done. That is it. So, I said I wouldn't go fast, but it looks like I might have, because we're already done. It hasn't even been 20 minutes. The section A, I mean. Maybe I'll go back and I'll just try to really explain each part of this. So to review, before we go, the median, that is the middle term. But not just any middle term, the middle term when the data has been ordered. So yeah, that's it. So you have to first order the data and then find the middle term. The mode, that is the most common value. This is the most common. With this formula, all we did was we substituted the values of A and B into this formula. All right, and this simply means this, right? 10 squared is 10 times 10. 8 squared is 8 times 8. Right? And the square root of 100, that's 10. Is 10 times 10 is 100. Okay. Next, we had a look at this fractions problem. We wanted to first find what fraction chose chicken. Right? To do that, we wanted to subtract the fractions that chose pasta and beef from the whole. And to do that, we had to reduce everything into a common denominator, common denomination. Right? Because remember that this is a law in arithmetic that you can only subtract and add things of the same kind. And so if we're dealing with thirds and we're dealing with eighths, we can't subtract eighths from thirds directly, right? So we have to reduce everything into a common denomination, right? So to do that, we can introduce a factor that will reduce our fraction to a common denominator. That happens to be 24 in this case, right? Common multiple between 3 and 8 is 24. So we introduced 8 to 1/3 and 3 to 3/8. Okay? And to the whole, we just represent the whole as 24 24ths. Okay? Then we just did arithmetic as normal. We just take away numerators from numerators, leaving 7 24ths. All right. So 7 24ths, 7 24ths of 240, that's 70. Okay. That was that question. Next, we did this final question. We have Roberto. He's painting advertising boards. We're told he has paint that can cover 10 meters squared, and he has 2 of these cans. Right? 2 liters. So we can cover 20 meters squared. Right? And from there, we have a constraint for this problem. We know that he can cover 20 meters squared. And now we want to see how much paint does he actually need? Right? To cover these advertising boards, how much does he need? What is the area of of 3 of them? So that's what we did. We analyzed one advertising board. Right? We analyzed it. We tried to find the area of one of these rectangular faces. We saw that that's actually 2 meters squared. Then we, analyzed it even more, figured it out that there's 3 of these rectangular faces. So we multiplied it by 3. Then we added on the triangular faces to get 6.24. Then we multiplied that by 3 because there's 3 advertising boards. We got 18.72, which is less than the paint that he has. And so, yes, he has enough paint. Many, many steps. Many, many steps. That is it. We are done. We are done. This is really all there is to it. We have section B left. All right. So next lesson we're gonna go through section B of paper 2. All right, guys. So I can see the chat going a bit. Yeah, I know it's a lot. The 6 marker, a lot. Totally, I understand. Yeah. But no, you can do it. We can do it. We can do it. Many steps, but it's very much doable. I know you guys can do it. All right. That's the hour done. I hope everyone has a lovely rest of their day. And tomorrow we're gonna continue with this. All right? Let me stop sharing. Wonderful. I'll see you next time.